Good afternoon. Hope everyone is having a great reInvent this year. And welcome to today's afternoon session. I am Kaushik Banerjee, client partner for Cognizant. My job at Cognizant is to advise clients on digital transformation. Over the last 2 years, I've been working with my client, Venerable Annuity, helping them migrate 100% of their workloads to cloud. We have achieved this feat in 18 months. I'm here today with Justin Kiefer, Vice President Venerable, to tell you about our migration story. The agenda today is mostly going to be focused on the lessons we have learned across the migration. We hope that these lessons will help you make your migration faster and better. With this, I'll turn it over to Justin, who will get us started on how this story started at Venerable.
Awesome. Thank you, Kaushik. So our story begins in 2017. A group of private equity investors approached Voya Financial looking to do two things. Number one, they're looking to acquire a large closed block of variable annuities. So a closed block is a type of block where basically they're not selling any new annuities from that block, so that's why we call it closed. And the second thing they're looking for is an operating company to become a new company to manage closed block annuities starting with the Voya block. So in December of 2017, that transaction was announced between Voya Financial and these group of private equity investors. And then June 1st of 2018 was the first official day of Venerable as a company. So you can think of Venerable as basically an annuity line of business from Voya. The June 1st date is also very important to this story because that started the clock in terms of actually separating from Voya. So the June 1st date was actually a legal separation, but that doesn't mean that the company was actually, from a business process point of view or an IT point of view, actually separated. So that June 1st date started a 24-month TSA agreement, which is a transition services agreement where Venerable agreed to pay Voya fees each month in return for business and IT services. So to kind of give you a context of what we moved, we migrated about 750 instances out of the Voya environment over into AWS, which included over 60 business critical applications. And in reality, we actually moved 500 tools, platforms, services, and applications. The list was actually quite intensive. In terms of our migration, the best thing about our migration was that we were able to leave our TSA 6 months early. And actually, that was 5 days ago. So this story is pretty new. Literally just happened.
And just to give you an idea of the kind of workloads that were moved, there were 2 large policy administration systems with service over 500,000 annuity contracts. A full annuity contact center was moved to cloud. And then there were applications related to financial risk, HR, accounting, which were also moved to the cloud.
So this presentation is really structured around kind of the major lifecycle items of a large-scale project. So we're going to go through planning and design and build and deploy. And as we go through each step, we're going to highlight some kind of key lessons learned that we felt that really stood out as part of this project. So the first one is developing a strategy first. As you're doing a large-scale migration, you have thousands of decisions to make. So if you can kind of set up a strategy and a framework ahead of time, that's going to accelerate your journey into the cloud. Also, use pre-built functionality. AWS offers tons of capabilities from services and quick starts that can really help you get going faster. Learning to deal with 80% of the requirements met. So as we did our migration, we came to certain inflection points within our applications and our platforms and our environments where we started to think about it from, are these must-haves or nice-to-haves? So we kind of started cutting stuff that we could do later because we had a very aggressive timeline. Moving data is tough. This was probably the biggest area that gave me the most heartburn was trying to get all of our data actually out of the Voya data center. So we're going to talk about that in a fun little story with Snowball. Spent a lot of time on cost governance. So something we learned, as we did this migration, is you need to kind of put processes and procedures in place up front so that you can detect when costs kind of go awry. And then one of the surprising lessons learned is AWS is also iterating very quickly on their platform. So as we started this migration and we moved along our path, we started using new services and new features, and it was jarring, but it was also really good.
Couple of critical success factors which resonates well with what Andy mentioned during his keynote yesterday. First of all, Venerable leadership was completely convinced with this migration. There was a top-down direction that this migration has to complete within 18 months. And between Venerable and Cognizant, we got the right skill set of resources for divestiture planning, cloud architecture, and cloud migration so that we could hit our timelines.
All right, so the first area we're going to go over is kind of the planning. So if you think about this in a chronological point of view, we're talking the beginning of 2018 until about the summer. So one of the first things that the business had to do was define what their business strategy is. So as an example, Venerable is not a retail institution. So we don't sell directly to end users or to customers. We're really focused on acquiring existing blocks of business and then managing that business. So that aspect really drove our IT strategy. So if you think through how we would grow, I can wake up tomorrow and we can effectively double the size of the company through an acquisition. So one of the biggest areas that we looked at from an IT point of view is scalability. Being able to very quickly take that block, suck it into our platforms, and then grow our business without friction. That was really the name of the game. So from the business strategy, IT strategy, we came up with a bunch of guiding principles that helped guide us through kind of the thousands of decisions that we had to make. And then once we kind of did that framework, then we looked at, okay, as we're doing this migration, how do we want to, at a macro level, kind of structure it? So we kind of came up with a 3-phase strategy. Step 1 was stand up fast. So speed was the name of the game. Step 2, kind of optimize. Okay, once you move everything, okay, now let's sit back and optimize it. Let's not try to do it perfect. Let's get it over, and then we'll work on making it better. And then prepare for growth. So after we came up with that framework and our guiding principles, the first major activity we did was we went through and looked at every single application in our environment, and we made a giant spreadsheet. We called it the Golden Tracker. It was the best. It was the bane of a lot of people's existence was this Excel spreadsheet. It basically listed all 400 plus platforms, tools, services, apps. And one of the columns was, okay, where are you going to go with this? What are you going to do with it at Venerable? So, there was a lot of change within the infrastructure area, the security area, the middleware and database. We actually made a lot of changes, because, for example, in our previous data center, we used a certain type of load balancer, and then when we moved into AWS, we decided to use Amazon's load balancer. And our guiding principles really helped here make a lot of these decisions very quickly, because we just looked at the list and said, hey, if Amazon has it, we'll use it. And then what we had left was things that we had to, for example, work with Cognizant on like our MFT system. Hey, what's some suitable alternatives? Do the research really quickly, make a decision, and get going.
So for the application standpoint, we had to answer a simple question, whether to retain the application, replace the application, or retire the application. We also had to make some decisions that if we were replacing an application, would we do some process standardization? We followed a framework for that. I will cover that in detail in a subsequent slide.
All right, so the next step of our process was the actual mechanics of migration. So what did we have to stand up to actually make the migration happen? So this is nothing to do with the end state of our environment. This is really a transitional state. So the first item we tackled was data center connectivity. How were we going to connect to the Voya data center to A, move our data, and B, allow our apps to talk back and forth? Because we're going to be moving our applications kind of in waves. Large data transfer. We had a lot of data. What tools and techniques were we going to use to actually move that data? Automation. We knew we had to build a ton of environments very, very quickly. So how are we actually going to tackle that automation? Application redesign and remediation. So each application had some work we had to do to move it. And we took all that data, all that activities, and through the help of our PMO staff, we made move groups. So, out of all those platforms, tools, services, we actually came down with 8 move groups. And then these move groups also touched upon like interdependencies between the move groups. So if an app moves in move group 5, for example, and it needs to talk to something in 6, do we have the right connectivity for that application still to work?
Now, to determine how to deal with the business applications, we use this framework called application portfolio rationalization. Out of the 400 applications that we had from Voya, 200 were business applications. Some of these applications were doing core business functionality, which you will not find in a product in the market. For example, the policy administration systems, which were homegrown, and we knew that those have to be transferred. However, for enterprise applications, there was a decision to be made. So we followed this process called application portfolio rationalization, where we had questionnaires out to business and IT, where we got information on the technology health, the business health, the risk associated with the application, and the cost of ownership. We put statistical models on this data and came up with a rationalization score. We also created 2x2 charts of business versus technology to figure out the cluster of applications which have the highest business and technology value. Those were natural fit to retain. And applications which had lower value in either technology or business, we could look at replacing them. Once the decision was made on what we had to retain, replace, or retire, specifically for the replaced apps, we had an opportunity to do process rationalization. We worked with business to determine what processes can be changed, because we were obviously building those applications from scratch. But we had the lens of doing things within the particular timeline, right? So we did not go so far into the blue cloud that we couldn't complete the transformation on time. For the retain applications, we had to determine how much replatform and remediation the applications had to happen. So we ran them through a Cognizant value stream mapping tool, which informed us, the tech stack suitability on cloud, whether there were any anti-patterns for cloud that need to be remediated, and gave us an overall complexity score. Based on that, we determined how much would be lift and shift and the kind of remediations that we had to do to move them to cloud.
All right, so if you're following along at home, we're in about the summer of 2018. So the next thing we did was we tackled design. So this is actually putting pen to paper and designing, okay, what's our future application architecture going to look like? What's our AWS structure going to look like? So the first thing you want to do when you decide to go with AWS is you go to the AWS website, you sign up, you create an account, and you have an account. Well, guess what? It's the same for businesses. I went into AWS, I created an account, and that became Venerable's account. So one of the first decisions you have to make once you have that account is how are you going to structure the account? So in a single account structure, basically everything's in one single account, and that's probably good for small workloads. If you don't have a ton of apps, you could probably get by with that. But any decent-sized business is going to want a multi-account structure. And the multi-account structures could take many forms. You can set the multi-accounts up by department. Say there's a finance account, an HR account, et cetera. You can set it up by projects. So maybe your business is focused on more kind of project work, consulting work. Or you can set it up to adhere to your SDLC. So in this example, there's prod accounts, dev accounts, test accounts. So you have the very first account you create is called your master account or your root account. And so if you think through the logistics of creating multiple accounts, you might foresee some operational issues. As you start creating all these accounts, each account is a separate copy of an AWS data center effectively. So how are you going to maintain operational integrity amongst the settings with all the accounts, security settings? So AWS does have a tool called Landing Zone. You deploy it, and one of the major benefits of it is a thing called an account vetting machine. So what you do is you kind of create a configurations of what you want an account to look like, and then from that account vetting machine, you can start creating other accounts. It will then keep track of kind of the configuration drift. You'll get alerts. Hey, this account's improper. It will take all the logs and put them into a common log account for analysis and debugging. There's a common security account. And it's really a way to kind of get you started very quickly with kind of an enterprise AWS account setup. So the next thing on your journey would be, all right, once you have your AWS account set up, you have all your VPCs, which are copies of your data centers. The next thing you want to do is kind of go through and look at your application architecture and determine how you actually want to deploy your architecture. So AWS has some pretty interesting tools around doing this very quickly. One of them is called the NIST Quick Start. So I don't know if everyone's familiar with NIST. Cybersecurity framework, it's something that the government publish with input from both private and public sectors, basically saying, hey, here's all the controls and processes that you want to follow to secure your cloud environment. So that's an excellent place to start. And what AWS has done with the NIST cybersecurity framework is they've done two things. So number one is they've created CloudFormation templates that, if your environment and your applications can use basically what's on the slide, they have a CloudFormation template that you can just deploy out of the box. It will configure all the load balancers, the subnets, all the constructs so that you can start deploying instances. The second thing we'll do is it will have a Excel sheet with all the NIST cybersecurity controls with a listing of exactly how that applies in the AWS environment. So this is a great thing to really get started, especially if you're in a regulated environment where you have to follow these controls, from an audit and insurance point of view. The other thing we noticed as we started this process was, we started getting some intangible benefits of just being in AWS. So for example, we started getting higher resilience because in each region of AWS, there's many data centers, or they call them availability zones. So we started having the ability to spread our apps across different physical facilities, which increase our resiliency. And then also from a security point of view, because we separated all of our environments by a region or a prod, dev, QA, we had a higher level segmentation. So we had a greater security posture just natively out of the box.
Okay, so now that he has set up all the infrastructure, we had to worry about getting the applications redesigned or remediated. For the applications which had to be replaced, we had a guiding principle that we wanted to look at lightweight solutions first, preferably if the solution can be on a SaaS, and more so if the SaaS is hosted on AWS. The first thing that we did when we were doing the architecture design was we created migration patterns. We looked at the different kinds of application on Venerable. If there were 3-tier applications, which are external facing, internal facing, 2-tier applications, how the applications will work with the different kinds of databases, be it Oracle, SQL Server, RDS. We created the migration patterns, looking at design principles on DR, high availability, scalability, and security, right? So once these standards were set up, then we had to map our replace projects as well as remediation projects to those standards to figure out how much work was involved. On the replace projects, I want to talk about 3 patterns. Specifically, I call that out. We had this application called Experience Studies, which was hosted on Oracle OFSA on the Voya side. We determined that we did not need such fat functionality on the Venerable side, so we wanted to redesign it using Python, and we used Amazon SQL RDS, which was a managed database solution, to move the functionality over. Then the next one that I will talk about was Contact Center. We moved it to a SaaS solution. It was hosted on Pure Engage, which was an on-premise solution on Voya, and we moved it to Genesys Pure Cloud, which was a SaaS solution, incidentally hosted on AWS. We did this project in 4 months time frame. There were nuances around setting up the network with our operations team in Philippines, but we worked through that, and that worked well. And then the third one, financial data warehouse. Here we decided to go towards a cloud-native warehouse that Amazon had. We went to Redshift, and we used the ETL tools that were available within AWS, Glue and Lambda, to get it started, and that's working well as well. On the remediation front, when we mapped the existing applications to our guidelines, the work that came out mainly fell into one of the four categories. There was technology currency upgrade that we had to do. The applications had to work towards the new security guidelines and tools that Venerable had decided. They had to work with the new middleware tools that we had come up with, and more tools that were involved, like business intelligence reporting, that were changed from what there was at Voya. And just to give you a high-level view of the kind of work that was done, just to give you a view of the kind of, and these are examples. This is not a full subset. On security, we integrated with Okta for user authentication. We used Secrets Manager for service IDs. We used SailPoint for IAM. We did not want to use DB2. We moved it to SQL Server. We did upgrades to a Sybase database. Middleware remediation, we moved web methods and IBM to Axway Secure Transport. And on the application side, we moved away from AIX to RHEL for a few applications, and we did the other remediations that were needed to make it cloud fit for AWS.
All right. So now we got all the planning out of the way. We did all the design work. Now was the fun part of actually doing the builds. The deployments, the QA testing, actually getting ready for that cutover weekend. So when we looked at kind of our automation and DevOps, like what we wanted to do at Venerable, so we had a decision to make. We could do a full CI/CD with kind of all the bells and whistles, with click button deployment of the apps. That would have taken us a little bit of time. So we kind of took a little bit of a hybrid approach. So the first thing we did was on the infrastructure automation, with Cognizant's help, they took an inventory of all of our applications, and we determined that basically all of our applications could hypothetically fit within 6 design patterns. So we took those design patterns after working with the app teams and security teams and said, hey, this is what we think is, you guys agree with us. We went through and took those design patterns and put them in the CloudFormation templates. And then the next step was we took our operational and security requirements, and then we put those into Chef. And then we used AWS OpsWorks as a kind of managed Chef environment, loaded all the cookbooks, kind of took both of those things, loaded them into AWS Service Catalog so that my team and other teams could actually rapidly provision these environments. Because remember from the beginning, we had about 750 to do in a few months' time. We did it. It was pretty awesome. And then on the DevOps side, the applications at Voya were in a mixed state. They were a couple of them were in different source control systems. So we consolidated to Git. For build and deploy, we moved everything to Jenkins. And then for Artifactory, we use that for our repository for artifacts. Now, our DevOps pipeline is actually fully featured. So it kind of has all the bells and whistles. But we did make some decisions around certain applications from a timing point of view. So our next steps with this is actually to marry the infrastructure automation and the DevOps kind of together to kind of create that click button deployment where an app team can go request an environment, they get one built to their exact specifications, and it works out of the box without any tinkering. Then the next thing was data transfer. So we moved a lot of data over our Direct Connect. So each move group weekend, we had to basically stop our databases, replicate a ton of data, get it in sync, and then start the databases up on the Venerable side. So our Direct Connect was used for that, along with basically application connectivity back and forth between the environments in our transition state. And then the other thing we had to do was we had to move a lot of kind of semi-static data, static data, or user data. So we use AWS Snowball for that. And the Snowball process is pretty simple. You go into the console, you click Snowball, type in an address, they ship you a Snowball, you plug it in, you spin up a whole bunch of VMs, you copy a whole bunch of data. It may take an hour, it may take 5 days, depends on how much data you have. And then you ship it back, and then in a few days it shows up in an S3 bucket. However, in our case, when we send it back, the console was stuck on importing, or I forget the exact word it was, but it was stuck there for a few days. So we opened up a ticket with AWS. They discovered that the Snowball device was actually damaged during shipping. So it was a bit unexpected, but AWS did recover all of our data very quickly for us. But it just goes to show that moving data is tough. You kind of have to plan for what if this breaks, what if this doesn't work, especially when you're trying to do a large-scale cutover where you need all that data in a certain time window. You need to have backup plans. So later in the project, we just started sending more snowballs. We're like, hey, it's really no difference sending 1 versus 4. Why don't we start to stripe the data a little bit and reduce our risk? And then a lot of the data that we did move in Snowball actually got moved to FSx for Windows. And this product had a bit of an interesting story for us. So when we first did the service mapping in, say, the summer of 2018, what we planned on doing was actually creating EC2 instances with EBS storage and having sys file shares just hosted like you normally would do in an on-prem data center. However, AWS during reInvent 2018 released a new product called FSx for Windows. So it was a fully managed Windows-based file share platform. So the team very quickly pivoted, and we decided to use that service because it would save us time. And remember, this whole project was about getting out quickly. So that's another example of kind of AWS iterating very quickly and providing new products and features that really, really help us out. So from an operations point of view, we've only been live for, officially our exit date was 5 days ago on the last day of November, but we have been live since September. So I don't have a ton of, operational data from a statistics point of view, but there's a couple of things I just want to touch on. So for monitoring, what we did with monitoring was we used Amazon's CloudWatch, and we did hook it up with our ServiceNow. So when we get alerts, a ticket's opened so that Purview team can respond to it. This would cover basic, kind of compute, network storage, like disk full, memory, CPU. And then we did deploy AppDynamics in a SaaS model for kind of deeper level application visibility. So visibility into like a JVM heap size or, connectivity issues between applications. And then, as the IT leadership team, one of our biggest goals was to make sure that we have an appropriate governance model put in place for our IT environment. So one of the big pushes for us was to kind of use ServiceNow as that kind of one place for all of our data. So we bought a bunch of modules within ServiceNow, like ITSM. One of the interesting ones we used is called ITOM. So ITOM has the ability to natively connect to AWS and kind of pull all those configuration items. So like S3 buckets, ELBs, elastic IPs, items like that. It has the ability to do orchestration. So we can create, simple workflows to like reboot a workspace or, provision an environment. And then it also has a cloud management piece where it actually will kind of suck in all the billing data so that we can cross-reference that with the rest of the data that's within ServiceNow. And then the last area I'm going to talk about really is around cost. So, if you've been in an on-premise data center, you're probably used to, every 5 years spending $10 million and, you have that equipment and whatever you can run on it, you can run on it. You don't really have to worry about cost. So with AWS, it's a little different. You're kind of paying as you go. So as you do your cloud migration, you want to make sure that you have controls in place kind of up front to be able to manage your cost. So for example, like in our case, when we first started, it was kind of very high level tracking. Hey, here's the infra bucket, here's end user services. And then as we got a little more mature, we started tracking it at the service level using tools within AWS like AWS Budgets and Cost Explorer. So for example, we were able to notice, we turned on a feature within CloudWatch called log ingestion. And we weren't necessarily aware of the cost implications of turning that feature on. So within a couple days, we saw that our CloudWatch bill went up 500%. So we backed that out really quickly. But I mean, that's, as more and more people get access to the console and configuration settings, you can inadvertently turn something on that you're not expecting. So that's really why you want to have a good method to not only track your costs, but understand where cost increases come from. And then the other thing is really around how do you save costs? One of the biggest areas that we've seen savings is what's called reserve instance. AWS has recently came up with a new thing called savings plan. They're effectively the same thing. Savings plan is a lot easier to use. But it's basically you make a 1 or 3 year commitment to AWS and they give you a pretty hefty discount on your compute spend.
Yeah, and to the theme of cost governance, once you migrate your applications to the cloud, you have to maintain them. So Cognizant worked with Venerable to come up with an application-based pricing construct, which was based on the complexity, the technology of the application, as well as the amount of work the application has in terms of incidents, changes, and service requests, which is again metric-based and comes back from ServiceNow. So I hope we talked about the lessons learned through all the different phases of the migration. We'll reiterate again why this is important, right? So why you need to develop a strategy first, you need to have guiding principles which come top down, which your organization follows. Be ready to create that rigor to take fast decisions. Work with a solution provider who can get you the data points, has the industry depth and expertise to give you advice, which will help you take decisions faster, which will help you go through with your migration. Using pre-built functionality, try to use templates that are available on AWS, or if you're moving to SaaS solutions, you use out-of-the-box features that they have as much as you can, rather than trying to build things greenfield, bottoms up, and trying to make customizations more and more to your products. It will really help you shrink your migration timeline a lot. And then learn to deal with 80% of the requirements met. You have to create a day-to list. Right? There will always be a wish list of items that come out of your design exercise that you need to do. But to hit your timeline, you have to take a call on which items have to be day one, and some items could be moved to day two. When we were looking at technology currency, for example, we decided to do struts upgrade as a day two item because it was not important to be done on day one. Even when we were doing replace projects, there were certain business functionalities which business asked for, which we decided to defer to day two. And now that we are on cloud, we are going to take those projects and move forward.
Yeah. And then moving data is tough. So this is probably one of the areas we probably should have spent a little more time on, actually understanding the ramifications of moving that much data. The snowball, things may break. You need to definitely have backup plans in terms of, okay, hey, that happened, what do we do next? Make sure you get large enough circuits, you have the right connectivity, because you're going to need it. Spend some time on cost governance. Even if you go in with a basic model, because you're going to see cost fluctuations, and it's tough to pinpoint exactly where that cost came from unless you have a good process in place ahead of time to be able to pinpoint that. And then the last one really is, AWS iterates quickly. So it may be a bit jarring to enterprises who are used to annual or biannually upgrades to their platforms. They do iterate very quickly. So, something that we may have had an issue with in the spring, they'll probably have a solution for it in the fall. So just be ready for that's a bit jarring.
And most importantly, embark in your first significant migration. There are a lot of experiences and lessons learned which you will gain as an organization. You will train your own people, and then as you do subsequent migrations, it is going to become faster. We are confident that once we have done this migration from Voya, the next migration that comes our way for Venerable could be faster and could be done in a much more streamlined fashion than we did the first time. With this, we would like to open it up to questions, if anyone has any questions that they would like to ask.
All right.
Good afternoon. Congratulations, by the way, coming in 6 months earlier on your migration.
Yeah, thank you.
Typically, it's 18 months after the fact. Going back on the cost, so you talked about typically you will forecast maybe $10 million for hardware, software, and then forget about it, right? How are you forecasting now since you pay as you go? So
Yeah.
I guess, day one, your bill might be $1,500, but how are you thinking about it 5-10 years from now?
Yeah, so our challenge was we had nothing to base it on. So there was no footprint that said, okay, hey, here's your footprint and here's what it's going to be in AWS. because the environment, on the Voya side was mixed, right? So a lot of it was shared with other applications, so we didn't have a clean, handoff. So what we did was we basically waited until we had a full workload, and then we kind of snapped a line and said, okay, these are the numbers. And then we basically started tracking over the past couple months, here's the numbers. And then as things deviate, my staff and the application teams kind of go through and, okay, where did this come from? And it's a little bit of a digging exercise in the beginning, but you start to kind of get good at saying, oh, this popped up. Okay, yeah, we know why this happened, then we can go back. So it really depends on where you come from. So if you have a very static environment that you just want to move, you can work with AWS and they can give you a pretty good estimate on what that's going to be. But our case, it was a mixed bag. Yep. All right. Well, thank you all for coming.
Thank you all for coming.
Appreciate the attendance.
Thank you.